For more than 40 years, Voyager 2 has been drifting outward, slowly leaving behind the familiar warmth of our Sun. It has moved past the last of the great planets, Jupiter with its swirling storms, Saturn with its delicate rings, Uranus tilted sideways in its orbit, and Neptune's deep blue winds. Beyond them, it crossed the icy frontier of the Kuiper Belt, a region of frozen debris and ancient objects that hold the remnants of our solar system's birth. And then, Voyager pressed on, into a region once thought to belong only to imagination and theory. A place where no human-made object had ever traveled before. When Voyager 2 was launched in 1977, the world was very different. Personal computers barely existed. The internet was decades away. The probe's memory was measured in kilobytes, far less than what a digital watch holds today. It was a fragile machine, built of metal, wires, and hope. Few imagined it would survive for decades. Its task was ambitious but finite, to fly past the outer planets, send back photographs and data, and then fade silently into the night. Engineers assumed that one day its batteries would weaken, its instruments would shut down, and its faint radio signal would vanish into the endless dark. It was supposed to go quiet, becoming just another piece of debris lost in the void. And yet, Voyager 2 defied every expectation. Nearly half a century later, it still whispers faintly across billions of kilometers, its signal taking more than 18 hours to reach Earth. And what it whispered recently was not routine. It was not ordinary telemetry. It was something startling, something that made scientists stop, listen, and rethink the very nature of our cosmic boundaries. The edge of the solar system. Voyager 2 had reached the edge. It had crossed into interstellar space. And in doing so, it revealed a truth long suspected but never confirmed. The border of our solar system is not a fading blur. It is a wall. And beyond that wall, the universe changes. That invisible wall is called the heliopause, the place where the solar wind, the constant outflow of charged particles from our Sun, finally loses its strength. Beyond that point, the forces of the galaxy take over. For decades, many imagined this transition would be soft and gradual, like a breeze slowly fading into still air. But Voyager's instruments told a different story. The change was abrupt, sharp, almost violent. One moment, the spacecraft was still inside the Sun's protective bubble. The next, it was thrust into an entirely different realm. Its detectors recorded abrupt surges in cosmic radiation, some rising by more than 70%. Plasma density jumped suddenly. Magnetic fields twisted and snapped into unfamiliar alignments. Crossing the heliopause was not like drifting into open space. It was like stepping into a storm. The living shield, the heliosphere, once thought of as an abstract concept, was revealed as something tangible. Inside, the Sun's outflow shields us, muting the chaos of the galaxy. Outside, that shield ends. And the galaxy shows its true face, restless, turbulent, and dangerous. Voyager 2, along with Voyager 1 before it, showed that this shield is not fixed. It breathes with the Sun's 11-year activity cycle. During solar peaks, when sunspots rage and solar flares erupt, the bubble expands, pushing cosmic rays outward. During quiet periods, the bubble shrinks, letting dangerous radiation creep closer to Earth. And the bubble is not symmetrical. It is stretched, compressed, and distorted by the galactic winds, pulled into a comet-like shape with a long trailing tail. The protection that guards our planet is fragile, flexible, and uneven. The silence of 2019. This fragility became alarmingly clear in 2019, when Voyager 2 suddenly went silent. Its instruments froze. Its transmission ceased. For hours, engineers feared it was gone forever, consumed by the cold, merciless emptiness of interstellar space. Then, without warning, the signal returned. The spacecraft had survived. The official explanation pointed to aging electronics and a temporary software fault. But buried within the data were stranger clues. Unexplained bursts of particle energy, sudden spikes in radiation, distortions in the magnetic field. Had Voyager 2 passed through an unknown region of space? Perhaps a pocket of highly energized plasma? Perhaps the fading remains of a distant supernova? Or perhaps something humanity had never imagined. A restless cosmos. Whatever the cause, the message was clear. Interstellar space is not calm. It is alive. Voyager's instruments recorded fluctuations in plasma density that rose and fell like waves on an unseen ocean. Radiation sometimes pulsed in rhythmic patterns, sometimes appeared without cause. Magnetic fields jolted and twisted suddenly, almost as though invisible storms were brewing in the dark. For the first time, humanity had direct evidence of space weather beyond the solar system. The galaxy is not empty. It is structured, turbulent, and ever-changing. The magnetic mystery. And then came the strangest discovery of all, the magnetic alignment. Scientists had long expected the Sun's magnetic field to clash violently with the galaxy's field at the boundary. Instead, Voyager found them strangely aligned, almost synchronized, as if they had been shaped to fit together. This raised profound questions. Has the heliosphere been sculpting the galactic field for millions of years, reshaping its surroundings on a cosmic scale? Or was our solar system born in a region of space already aligned with the Sun? If the first is true, then our star is far more powerful than we realized, capable of reshaping the galaxy itself. If the second is true, then our cosmic neighborhood is not random, it is ordered. And perhaps it is part of something larger than we can yet imagine. A threshold, not a border. From these revelations, a whisper began circulating among theorists. What if the heliopause is not just a boundary? What if it is a threshold, reactive, maybe even watchful? The sudden spikes in radiation, the sharp magnetic shifts, the strange alignment, all hinted that the heliopause might be more than a passive bubble. Some speculated it could act like a natural checkpoint, a structure that registers whatever passes through it. If true, then Voyager 2 did more than simply drift into interstellar space. It announced itself. The golden record and what it carried across that threshold makes this thought even more haunting. Attached to Voyager 2 is the golden record, a copper disc plated in gold, engraved with music, sounds of Earth, greetings in dozens of languages, and a star map pointing back to our world. For decades, it has been celebrated as humanity's most hopeful gesture. A message to the stars saying we are here. But now, in light of Voyager's discoveries, some wonder, was it also a risk? If the heliopause reacts, if it signals, then what does it mean that the first probe to cross it carried a message pointing directly to us? Did we extend a hand of friendship? Or did we reveal a weakness? A messenger in the dark. Voyager 2 was never designed to confront such questions. And yet, here it is, still drifting, still speaking, still carrying humanity's voice deeper into the unknown. It has shown us that our solar system is not unprotected, it is wrapped in a living shield. But that shield is fragile, and beyond it lies turbulence, storms, and forces we are only beginning to understand. The heliosphere is not simply a bubble. It is a threshold, dynamic, reactive, alive. And Voyager 2 has crossed it. Now, nearly 50 years after launch, it continues its lonely journey into the vast unknown. What it has already revealed is extraordinary. The galaxy beyond is not silent. It is structured. It is restless. And it is far closer than we ever imagined. The lingering question echoes across the silence between the stars. Will Voyager 2 remain only an explorer? Or, by carrying its golden message beyond the boundary, Has it become something more, an announcement to the cosmos that we are here?